Voyager 1 was launched in 1977, and to this day it remains the most distant human-made object ever sent from Earth. It is currently about 15.9 billion miles away and continues to move farther from us at roughly 38,000 miles per hour, about 11 miles per second. Despite this immense distance, we are still able to communicate with the spacecraft. The real question is, how can we send commands to something so unimaginably far away, and how long can that communication realistically continue? Many people do not realize that Voyager 2 was actually launched before Voyager 1. Voyager 2 lifted off on August 20th, 1977, while Voyager 1 followed about 2 weeks later on September 5th, 1977. Technically and structurally, the two spacecraft are almost identical. Their primary mission was to closely observe the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. Achieving this mission required more than just powerful rocket engines. Mission planners took advantage of a rare planetary alignment known as a gravitational slingshot or gravity assist maneuver. At that time, Jupiter, Saturn, Uranus, and Neptune were positioned in such a way that a spacecraft could use each planet's gravity to gain additional speed and redirect its path. This alignment is extraordinarily rare and will not occur again until after approximately 2150. Voyager 1 first flew past Jupiter, sending back images that stunned scientists. It revealed the planet's turbulent atmospheric storms, faint ring system, and confirmed active volcanoes on its moon Io, the first active volcanoes ever discovered beyond Earth. It then traveled to Saturn, where it closely examined the planet's rings. Voyager discovered Saturn's shepherd moons, small moons that help maintain the structure of the rings. Even more significant was its observation of Titan's dense atmosphere, composed of roughly 90% nitrogen. After completing its planetary exploration phase, Voyager 1 began its journey toward the outer boundary of the solar system. Meanwhile, Voyager 2 followed a different trajectory. It continued on to Uranus and Neptune, two planets that Voyager 1 never visited. Voyager 2 remains the only spacecraft to have provided detailed close-up images and data from these distant ice giants. Although Voyager 2 was launched first, Voyager 1 is now farther from Earth. The reason is simple. Voyager 1 is traveling slightly faster, about 10.6 miles per second, compared to Voyager 2's 9.7 miles per second. The difference is only 0.9 miles per second, but across the vast scale of space, that small gap has translated into an enormous distance over time. Both spacecraft have now crossed the heliosphere and entered interstellar space. The heliosphere is a vast bubble created by the solar wind, marking the outer limit of the sun's direct influence. However, the solar system itself extends much farther. For example, the Oort cloud lies well beyond the heliosphere. It is estimated that it will take the Voyagers around 300 years to reach the Oort cloud and approximately 30,000 years to pass through it completely. Despite being so far away, communication is still possible because of their highly precise radio systems. Each Voyager carries a radio antenna about 12 feet in diameter, transmitting a narrow radio signal with only 22 watts of power. That signal takes roughly 22 hours and 30 minutes to reach Earth. For comparison, light takes just over 1 second to travel from the Moon to Earth. As radio signals travel farther, they weaken according to the inverse square law. By the time Voyager's signal reaches Earth, it is only a tiny fraction of its original strength, trillions upon trillions times weaker. To detect it, NASA relies on the NASA Deep Space Network, a global communication system equipped with massive 230-foot antennas located in California, Madrid, and Canberra. These three stations ensure that at least one antenna is always pointed toward the spacecraft as Earth rotates. The Voyagers do not use solar panels for power. At such extreme distances, sunlight is far too weak. Instead, they rely on radioisotope thermoelectric generators, which convert heat from decaying plutonium into electricity. At launch, each spacecraft generated about 400 watts of power. Today, that output has dropped to below 200 watts, forcing engineers to gradually shut down non-essential instruments. The famous pale blue dot image of Earth was one of Voyager 1's final photographs. After that, its cameras were permanently turned off to conserve energy. Currently, only a few scientific instruments remain active on Voyager 1, mainly those measuring magnetic fields and charged particles. These instruments continue to provide valuable data about the interstellar environment. Despite multiple technical challenges over the decades, NASA has managed to maintain the spacecraft through software updates and strategic power management. However, as energy levels continue to decline, it is estimated that communication with Voyager 1 may cease entirely around 2035 to 2036. Originally designed for just a 5-year mission, the Voyager program has now operated for more than 4 decades. With limited memory, slow data transmission rates, and technology from the 1970s, Voyager 1 and Voyager 2 remain humanity's most distant messengers, traveling silently into the unknown, carrying our presence deeper into the cosmos. That's all for today. See you in the next video.